Hi, welcome to the course. My name is Fuad, and this video series will help you understand your reading material, assessment, and health professions education. Now, I'll point out to you in this series what's important, what's not so important. So let's go right to it. Now, it goes on the class, the chapter goes on to describe standard error of measurement, SEM. Now this is important. It is like the basis is that if you ask a student to take a test or a group of students to take a test, the student will get a mark, and if you ask them, ask him or her or the students to repeat the test again, they will get another mark, and we assume that this is due to the error based on CTT, and ask them to do it again and again and again and again and again infinitely. Okay, so if we plot the frequency distribution curve for these marks, then what we will get? We will get a normal distribution. And the calculation of this normal distribution is called as the normal distribution of these measurements is called as the standard error of measurement. Now the curve tells us that helps us in calculating how confident are we if a student, again, let's say I take a test and I get a mark of 49.5, and when we calculate the standard error of measurement, it is for easy calculation or for discussion, standard error of 1. So if we use the standard error, and I will be confident that my true score will lie somewhere between, so 49.5 minus 1, it's 48.5, and plus 1, 50.5, right? So my true score without the error is somewhere in there. Okay, so that's the use of SEM. It will be useful later on in many calculations, even in standard setting, the concept of standard error of measurement, and regarding how do we tackle borderline students and things like that. So SEM is quite a useful concept. Okay, and in the implications part, page 45, the author pointed out that some places or some books, some literature, they calculate or they multiply the SEM by 1.96 to obtain the 95% confidence intervals. Okay, if you recall your discussion about the normal curve, then if you go one standard error, and it covers a certain proportion of chances. Okay, so please be aware of that. However, that it says here, in practice, educators often use plus minus 1 SEM to construct the 68% confidence interval. So we do not go by 1.96 or 1.65, we just go by 1 above and 1 below the mean of the measurement to get a 68% confidence interval, as this yields a more practical degree of measurement intervals. Okay, so another point is that this SEM, standard error of measurement, should not be confused with standard error of the mean, which is a different statistic. So goes on to explain what's the difference between the two, so please be aware.